Caesar Cipher. To encrypt a word by Caesar Cipher, you shift every word in alphabet with a certain number. For example, with a shift of 1, A becomes B, B becomes C, and so on. When you reach to the end of the alphabet, you simply wrap around to the beginning. Now that I've explained how Caesar Cipher works, I can move on to explain the Python code I wrote. That's the file structure of the project. We have the main file. Then under utils folder, we have encrypt.py file. Next to it, we have decrypt and words.json files, which we use to brute force the encrypted words. We'll move on that later. But first, we should understand how encryption works. This is the encryption code. We have the encrypt function. Here, the program encrypts it with word and shift that are chosen by the user. To encrypt, we go through a list that contains each letter of the word. Then we add the shift to the index of the letter. For example, A is the first number in the alphabet. If we want to encrypt it with shift 4, we get 1 plus 4th number. So A is encrypted to the 5th character of the alphabet, that is E. To wrap around to the beginning, we use the arithmetical formula of Caesar Cipher. Basically, to encrypt, we add the shift to the number, then take the mod 26 of it, because there are 26 letters in the alphabet. Decryption. I wrote a decrypt function to brute force encrypted words, in case we don't know what the shift is. This is a bit complicated than encryption, but clear. First, I found a GitHub repo that contains all words in English in JSON file. After that, I tried all possibilities that the shift can be. Then, if we match one of the possibilities from words.json file, we print the found word. I'm planning to add a decrypt function to decrypt sentences in the future, either with matching of the frequency distribution of the letters or machine learning. If you have any further suggestions, you can leave a comment and you can find the GitHub repo at the description. Have a good time.